This is Math 261, Section 12.2 on differentiation and integration of vector-valued functions. And this is Part 6, Page 6, Example 5, with 4 parts to do, the first of which is to find r prime of t. So let's dive right in. We have 5/2 times 2t I minus 3 times j, derivative of 3t is 3, plus 1/2 times 3t squared times k. Which is cleaned up a little bit, gives us this for the derivative. Part B is the second derivative. So our double prime of t would be 5i minus, now the derivative of 3 is 0, j, plus 3/2 times 2, t, times k. Now in part C, we have to calculate a dot product, r prime of t times r double prime, dot product, r prime of t dot product, r double prime of t. So we have this vector-valued function dot product with this one. This is the formula for the dot product. So for part C, we go like so. Writing part C, the dot product in component form would be like so. So not necessary to do that, but sometimes things are a little easier to see in component form for graphing or for this purpose. There's the 5t, so there's 5t. Second component is negative 3t squared, 3/2 t squared here. Then this would be 5, here's 5, 0 because that was 0j, and 3t. I had a mistake up here, that was 3. This is right. Yeah. And I had missed the t right here. Okay. And then to do the dot product, and multiply 5t times 5 would be 25t, negative 3 times 0, 3/2 t squared times 3t. Part C. And now in part D, we're supposed to do the cross product of r prime of t, which is here, cross r double prime of t, which is here. So to do the cross product, we have to set up an array where we have ijk, and then we have the vector r prime of t, and then we have the vector r double prime of t. Then we copy over the first column and the second column to create a grid of 3 rows and 5 columns. Then we're going to have 6 terms in the dot product. 3 of them come from the green diagonals. The first one would be negative 3 times 3t would be negative 9ti. Second one would be 15/2 t squared j. The third one would be 0. And then we have minus 3 more terms. And those terms are going to come from the blue diagonal. So the first one is going to be negative 15k and then plus. Second one is going to be 0 because of the presence of this 0 here. And the last one is going to be plus 15 t squared j. Should be a j in this term here. So plus 15 halves t squared j. And then plus 15k, and then minus 15 t squared j. And then negative 9ti is by itself. There are two j terms, 15 halves t squared and minus 15 t squared. So 15 halves minus 15 is negative 15 halves t squared j, and then 15k is by itself.